Hi friends, welcome to GMK Tutorials. In this video, we are going to see about the analog communication, analog electronic series pointer. So just we will go through the CMOS discussion also. Okay. So in the last video, we discussed regarding what is meant by MOS transistor, what is meant by PMOS, what is meant by NMOS transistor, how we are going to designing the CMOS circuit, and how it acts as an inverter. So that is all those topics already covered in the last video. Now in this video, we are going to design a logic gate with the help of a CMOS technology. Okay. So basically, what is meant by logic gate generally? So logic gate means logic gates are logic gates means obviously that is nothing but AND gate, OR gate, and NOT gate. So obviously this is already completed. Okay, CMOS acts as a NOT gate. So now we have to design AND gate and OR gate. So before this discussion, just I have to give some important points related to for this one. So generally, suppose in case of suppose let it be take f is equal to AB. Okay. So if you want to designing a circuit for this function with the help of a CMOS technology, so how it is possible? So wherever the product terms are there, so that can be represented with the help of a series connection. Okay, that is very important, guys. Okay, that can be represented with the help of a series connection. So AB is nothing but obviously series connection means this is a fashion. Okay, this is a fashion. So obviously in all cases, okay, the pull-up network is always PMOS transistor. Okay, it is a PMOS transistor. So therefore you will take like this. Okay. Suppose if you are taking a NMOS always in the pull-up network, it can be treated as A and B. Okay. So at the same time, for this one, quite oppositely, that is nothing but for this case. So these two are connected in a series. So obviously these two are connected in a parallel fashion. Okay, it is a one NMOS transistor. It is also called as a one more NMOS transistor. Therefore, if you are connected like with some signals, so this is the connection for A. Just this is the connection for these two. So whatever the point we discussed in the last video, always the source terminal of the PMOS transistor are connected to the higher potential and the lower potential is connected to the source of the NMOS transistor, right? So this is a discussion for suppose this is also one kind of citizen. So the main important consideration is nothing but so in this circuit, so it is very important. So here, so series fashion means that obviously whenever these two PMOS transistors are on, then only will get some value. That means whenever this condition satisfied, that means both PMOS transistors, both PMOS are on condition, then only the output is high. That is the criteria, right? So what is the criteria? So but there is a in case any one of the NMOS is on condition, obviously will get a higher value. So that means let us see the truth table for this one. 0 0 0 1 1 0 1 1. In this case, this is only valid for 0 0 case only. Okay, it is only valid for 0 0 case only. Okay, 0 0 case only. Why it is 0 0 case only? Why? Because let us see here. So whenever 0 0 means that these two PMOS transistors are going to be on condition. So in the remaining consideration 0 0 or maybe 0 1 consideration, one PMOS is on and the other one is off condition. 1 0 half on. So 1 1 both PMOS are going to be half state. So that means there is no supply from the VDD. Suppose if you are taking the output here from this value, just you will get, so that means the circuit performs the whenever 0 0 is there, at that time only the circuit acts as a on condition. So this is 0 0 1 condition means that in the remaining all consideration it is going to be 0. That means this output is generally, this is also called as this truth table is similar to the NAND gate. Okay, that means if you want to design a AND gate for this one, just you have to connect the one inverter circuit for this one simply. Just you have to connect the one inverter circuit. So for this one, so just take a two one PMOS and one NMOS circuits, then you will get a AND gate output. Okay, so this is nothing but a PMOS representation. This is also connected as a VDD. Suppose if you want to connect it from this to here also, there is a connection also. So in case if you are representing, so this is nothing but the output is also equal to the, now in this case, suppose if you are getting a 0 0 consideration, 0 0, these are going to be high output, therefore you will get a 1 value. So so the one input is applied to the CMOS inverter, you will get a value of 0. Therefore, in this case, you will get a value of output 0. So what is the truth table? 0 0 consideration, you will get a value of 0. Okay. So if you are taking the 1 1 consideration, so let us see in the second consideration, when both inputs are 1 1 state, what happens? 1 1 means that obviously both PMOSs are going to be half state, output here 0. Okay, so 0 can be treated as a 1 for inversion. Therefore, when 1 1 is nothing but the output can be 1. So when the 1 1 condition at the time, it may be get. That means in the 0 1 combination, suppose if you take one more combination, 0 1 consideration, 0 1. So just I will take one more color, 0 1 consideration, 0 and 1 consideration. 0 means that on condition, 1 means that off condition. So we don't have any short circuit from VDD to this point. So that's why it is in a half state. That means only 1 1 condition only will get a value of high output. So that's why it is generally called as a AND gate realization. Okay, that is important, right? Suppose if you go for the OR gate realization, it is a quite opposite for this one. So in case of the OR gate, what we are going to be done is nothing but, in case of the OR gate realization, it is a quite opposite to this one. So we don't want to think about opposite or maybe similar fashion. Instead of that one, just we have to follow the logic only. Okay. So OR gate is nothing but, basically OR gate is nothing but A plus B configuration. Okay. As I said earlier, product term can be represented in a series fashion and parallel can be performed with the help of a, like whatever the simple things you can go for, maybe control systems are like this. Whenever series are going to be there, at that time will perform a resultant value is nothing product of their individual blocks, right? Suppose if you go for, in case of the anything, okay, see here, so here also same thing, just you have to think like this, just you have to link up that one only. Okay, so therefore A plus B is nothing but, it is nothing but it can be established, it can be designed with the help of a parallel connection only. So from that basic criteria, just I have to design a circuit for this one. Okay, so parallel connection, obviously always most of the cases just you have to use only PMOS transistor. Okay, so just I have to represent it instead of bubble, just I have to represent like this. So it is also a PMOS transistor, maybe bubble or like this also. So these two are connected in this fashion. Okay, now these two are going to be connected like this. So this is connected. That means higher potential is nothing but VDD is connected to the source of the PMOS transistor. At the same time, in the downward direction, so in this configuration, what is the basic logic here? You have to follow this one is nothing but, suppose there is a possible combination 0 0 0 1 1 0 1 1. I don't want to think about this OR gate or AND gate. So these two gates are PMOS transistor is on for 0 logic only. So that means this is also valid case, valid. That means these three possible combinations, obviously any one of the gate is on condition. Any one of the gate is going to be on condition. That means, so there is a connection for this one. There is a connection, you will get output for any three combination, but except this condition. So this condition is not valid here. That means not valid means that whenever both logics are 1 1 at that time, so those PMOS transistors are going to be in half state. So that's why at that time we don't have a supply from VDD to the output side. So that is very important criteria. So the remaining pattern is nothing, that is very clear. Okay. Obviously, if you are connected like this, the remaining pattern should be opposite to this one. So here CMOSs are connected in a parallel, then you will connect the NMOS transistors in a series fashion. Okay. NMOS transistors are going to be connected in a series fashion. Why series fashion? Suppose if you are connected in a series fashion, what is the possible for this one? So just you will have these two values. So this is the one gate input. So this is the another gate input. So this is nothing but A value and B value. So AB means that obviously you will suppose if you are still connected in a, these two are so parallel, what happens is that so these two combinations are going to be on condition. So at the same time these two are going to be let us see here, but just I have to suppose the same circuit is also connected in a parallel. Let us assume that so this NMOS is also going to be connected like this. What happens? So up to this one, you will get a output value for any one of the case 0 1 0 0 or maybe 0 1 and 1 0 will get a value of some high output, right? Suppose if you are taking some high output for maybe 0 1 consideration. Suppose if you are applying a 0 1 means that it is also can be treated as a NMOS 0 of 1. That means you will get a value of 1 means that it acts as a short circuit. Act as a short circuit. You will get a value of 0. Right? So you will get a value of 0. Is there any possibility such a kind of gates are available? So one case is also nothing but it acts as a short circuit. Okay, but it acts as an open circuit. So is there any possibility? You have to think about it. Okay. So there is a gate for realization of this one. Okay, just I don't want to go for this one. It is not a, so this truth table is not valid for the logic gate. That's why I don't want to think about it also. Okay, just I don't want to think about it also. Just so this is the connection pattern, right? Now, so this is the fashion, right? So just up to now you will get a value of certain A B is nothing but you will get a, it satisfies this consideration. Okay, suppose so here the value of 0 0 on condition 1 1 1 just you will get a value. So that is nothing but it is similar to the OR gate, right? It performs the OR gate operation. No. Okay. So in case of the OR gate you will get a value of 0 and 1 1. So this is OR gate, but it is opposite to this one means that obviously so A plus B OR gate realization, right? So OR gate means that 0 1 you will get a value, right? 0 1 1 0. So let us see here, guys. So actually this is a small correction. That means it does not satisfy all the values. Just you have just you will go for this one. It may be OR gate, AND gate operation. Just you will check only two considerations, right? So in the 0 0 combination, by the time these two PMOS transistors are going to be on condition, therefore you will get a high output. At the same time, in 1 1 condition, both are going to be half state, right? So 0 0 combination, you will get a value of on and you will get on value 1. So in this case, just you will invert this one, just you will get a value of this one, right? So 0 0 combination, you will get a value of 0. So what about the consideration of a 0 1 consideration? So 0 0 will get a value 0. Okay. So this is the case for this is a scenario for AND gate. You will get a value of this one. What is the value for this one? Just so you will check it once. So AB 0 0 0 1 1 0. So it is a quite opposite to the AND gate. So it is not an AND gate also, right? So similar to the NOR gate, right? Similar to the NOR gate, right? So NOR gate in case of the 0 0 0 1 1 0 1 1. So OR gate means that 0 1 1 1, but you will get a value of 1 0 0 0. So that's why you will get a 1000 is nothing but it performs the NOR operation. That means it is not a NAND gate, so it is not a AND gate, it is nothing but a NOR gate realization structure. Okay. So here you will see the same consideration for this one. So it is nothing but a NOR gate, just a small correction for this one. Just we are not defining any gate, just it is a universal, just to think about it. Just a small change, guys. Just you have to change, just so we will take only two considerations. So that's why we'll think about it. Just it is nothing but a, just I don't want to think about for just by heart for this one. Just you have to go through the concept oriented only. Okay, it is nothing but a NOR gate realization. So it's not an OR gate, it is nothing but a OR gate realization or NOR gate realization. So 0111 just means that it is nothing but a OR gate realization. Okay, OR gate realization. Okay, so it is nothing but a AND gate realization. Okay, AND gate realization. So for this one, you have to check each and the case. Just you have to check then only it is valid for this one. Okay. So AND gate consideration, what happens is that suppose if you are going for the analysis point of view, just I have to take only some consideration. Just you will take 1-1 combination first. So 1-1 means that obviously this is going to be half. So both transistors are going to be half. Therefore, output is equal to 0. Suppose output is equal to 0. Okay, fine. 1-1 is nothing but output value is 0. Next is 0-1. 0-1, what happens? So 0-1-1-0 case, not a 1-0. It is a 0-1. So 1-0 case, which I will think 1 and this value is 0. So 1-0 means that obviously, so 1-0 case, what happens? So 1-0 half state. So this one on condition. So for 0 case, what happens? It is a on condition. So 0 condition, it acts as a half. So we don't have any short circuit. Just you will get output is equal to high output only. So that means for 0-1 case also you will get a 1 output. So it is also valid maybe. For 0-0 case, what is the scenario? So 0-0 means that both there is a connection for this one. These two also going to be half state. So that means only you will get a high output. So this is very important. Just you will get a high output also. So 0-0-1. So in 1-1 case only you will get a 0. So this is a valid for 0-0. What is the gate of this one? 0-0 you will get a value of 1. 0-1 you will get a value of 1-0. That's just, it is nothing but opposite to the NAND gate realization, right? So NAND gate only you will get value of 0 and remaining all cases you will get a value of 1. So that is nothing but it is a NAND gate operation. So that means it supports a NAND gate. Suppose in case if you want to designing a AND gate realization for this one, just you have to connect one more inverter for this one. Just you will get the value of AND gate output. Okay. So this is the consideration. So it is very important, guys. Just you have to think about the analysis on just this nothing but output. So this is generally called the AND gate realization. Okay. I hope it is very clear, right? Just if you go for the another case. Another case. Suppose if you want to design if you want to design any function, suppose if you want to take any function, suppose f is equal to x into x plus y. Suppose if you want to realize a function like this, or maybe if you want to design a function like this, just take like this, or maybe take any function as your wish. Okay, suppose I will take a into b plus c. So this is the function. If you want to design with the help of a CMOS circuit, just how you are going to design a circuit lab, just how to think about it. So first of all, as I said earlier, b plus c, there is nothing but OR operation. OR operations means that obviously in case of the OR gate, the OR gate realization, these DMOS are connected in a series fashion. Just if you have a remember that point, you have to go through that concept, or in case just you will go for the normal case operation also. So b plus c is nothing but what happens, b plus c, that is not addition. So for addition point of view, just you have to connect in a parallel configuration. That's a very simple easy. Okay, so parallel connection. So this is nothing but these two are a PMOS transistors. So PMOS transistors are connected in a parallel fashion. So it is a source also connected to the high VDD or maybe higher potential. So B plus the addition is over. Now this is nothing but a product operation. So therefore for product operation, just you have to connect in a series fashion. For product operation, just you have to connect it in a series fashion. So series for this one. So it is also this one. Okay. Now these are all connected in a series fashion, right? Now these two are in a series. Therefore, it is also connected in a parallel fashion. These two are connected in a parallel fashion. It is very important. Parallel fashion. Then what about this one? So these two are connected in a parallel. So it is a series. Again, it is a for this one case it is a series. Now in this case you will get a parallel output only, right? So these two are connected in a parallel, but you will get a value of this in a series fashion, right? Just think, guys, it is a small difference, right? Just this page is not sufficient for this one. Just wait. So up to now it is clear, right? So this is only parallel connection. So for this you have to connect it a series fashion. So this is also NMOS transistor. Just you will connect it like the series fashion. So this is connected in a series. Now it is connected in a parallel connection only. So that is a important consideration here. So this is a circuit for this above function. Okay, suppose if you are connected the input like this, just you will make a connections and all those things. Okay, so this is a B, just A. Okay, so it is A, actually it is nothing but a BC. A, you will get a value of, it is a B, it is a C. At the same time, this output is just you will get a value and these two are a BC value. So this is nothing but any function can be realized with the help of a CMOS circuits like this only. That is a very important observation here. Okay. So thank you guys. Thank you for watching GMT tutorial.